So hello everyone. Yeah, today is the last day of OCP Summit. I hope everybody have a great experience and learn a lot from this year's show. I'm Gavin Wang from Aivres, and I'm here to share with you how AI technology is driving changes across data center industry. So first, let's go over some of the major current trends. So one is explosive growth of large language model computing resources, growing AI factory, and technology innovation. So large language model have grown to billions of trillions of parameters. So advanced the model capability, algorithm, and also the model architecture are driving up computing requirements. So we think open source and agile development of system design is needed to meet the market demand for system to support growing AI. So sustainable growing AI factory is another trend. So AI task, large language model, recommend system and the massive data analysis require extreme scale capability of compute resources. In green computing of the AI, applications are reconstructed by adding GPU for increase the throughput, reduce energy uses, and optimize the cost efficiency. Sustainable ability is achieved whole system architecture design. So intelligent management and liquid cooled design to reduce energy consumption. So next is the trend is the compute, the power. So you see the scaling law, so lead to continuous increase in the parameter of dense mode. So mixture of the aspect MOE we know. So it's becoming the mainstream architecture. So frontier the model as seen in GPT-4 and mixture. So which use 4D parallel algorithm and O2O communication strategy. So long sequence are also become important feature for frontier model with global attention strategy and also the KV cache memory. So those all require so large GPU and bandwidth domain. A large GPU interconnection domain can achieve higher bandwidth and lower latency. So for training, we see the more model parameters and the natural language layers. The more GPU are needed to just store the model. A large interconnection domain can accelerate the transition of this massive information between the GPU, introduce just the data transition and the training time. For inference, we see so multi-GPU can process different parts of input data in parallel and can then quickly merge the result through the interconnection domain. The high-speed data interconnection can quickly integrate the calculation of the result for the each GPU, increase the inference speed, especially for large-scale input data and the complex the model structure. So one of the biggest the challenger of the AI cluster, so our system level the limitation. So we can overcome this, so we scale up and also the scale out architecture to build a high bandwidth domain for the data center. The memory wall is a major challenger to store the model parameter. Green is optimized the status. So you see, so 100 billion parameter model, so you need 3 terabytes of local memory. And also the large language model size is increasing faster than memory can keep up. So similar limitation in computing for training 10 billion parameter models, like hundreds of the billion of the token, massive data volume, and the diverse data type. The communication challenger involve the Tencent parallel and the stream parallel and also the data parallelism with different bandwidths. So basically, so computing infrastructure needs the local large memory, so high bandwidth, and also the network architecture. So in the future, the data center, we think we need to design both the scale up and also the scale out network simultaneously. So the scale up network can achieve higher communication bandwidth and lower the latency. It usually used for Tencent parallel in large model training and build a very large high bandwidth domain to design to improve the training performance. Also, we think the native memory and the link reliability we need to design to consider. The scale-out network is used for stream parallel, and the data parallelism is for large model training. Also support the GPU direct RDMA technology that can achieve the horizontal expansion of east to west data in the data center. So what are some of the solutions we have to address those trends and also the challengers? So there are three key architectures we think to support and drive AI in the modern data center. So first, we see is NVIDIA, the Blackwell GPU. So this architecture defines a new chapter of in generative AI and accelerated computing. It will bring unparalleled performance, efficiency, and scale. Second is Grace GPU. It's designed for a new emerging data center, AI factory that process and refine a huge amount of data to produce intelligence. Third is Bluefield DPU. It's transforming the traditional computing environments into the efficient, high-performance, secure, and sustainable data center. So we think rack scale will be the major product to future data center deployment. So currently, you see our liquid-cooled rack scale product, we use 8 GPU as a building block. So in a single rack, in a single block, it scale up to fully connect 8 GPU through a 900 gigabyte high-speed interconnection. So support 1.2 terabyte of local memory in the same domain. The 6 subsystem in a single rack can just up to 48 GPU, a whole system through 3 terabyte scale-out network. So Aivres, we working with NVIDIA to release the GB200, the rack solution. So enabling remarkable 4 times faster training for large language model at scale, and around 30 times faster real-time large language model inference performance. So we take very careful of everything from design to deliver of the cluster. So we offer cluster end-to-end solution with compute, storage, and network. So we also provide a data center management solution, include health monitoring, issue alerting, and job scheduling to cross diverse application scenario. We also offer cluster design optimization for large language model, which up to 100 billion parameters. On cluster deployment, we offer full stack optimization on AI infrastructure to help customer improving their computing efficiency. We can just achieve a recovery time of less than 5 minutes, or reduce the cleaning time of 1 petabyte, the data, from 30 days to 15 days. improving the accuracy of test filtering review from 80% to 95%. We also provide the model development toolkit for customer can accelerate their model and application development and deployment. So that's all I have for today. Thanks for joining me to hear about the trend, challenges, and also the solution for the AI data center. Please feel free to visit Aivres booth at C2 if you have a further question. Have a great rest of OCP Summit. Thank you.